Chapter 11 gives us more details into how we are impacting aquatic biodiversity. So Chapter 8, you looked at different types of aquatic ecosystems, and now we can look at how we're affecting that in more detail. So nice case study about whales. If you've ever been on whale watch, you might be familiar with some of the whales that are in this area, but let's get into what we do know. And we have to start kind of with what we don't know. There's a lot we don't know about the ocean. So it's more difficult to protect what you don't know and what you can't see. So we need lots more data about the ocean. And I always say we know more about the moon than our own ocean ecosystems. So keep that in mind. So that HIPCO acronym, right? Habitat destruction, invasive species, population growth, pollution, climate change, and then O here, overfishing. Definitely applies to aquatic ecosystems as well. So there's a lot of information about habitat destruction in Chapter 8 and how that's happened. So if you need to review that chapter again, please do so. And then this chapter has tons of examples of invasive species and how they've affected both freshwater and marine ecosystems. I'm going to give you examples with the lionfish and Nile perch in Lake Victoria and carp in lakes around here and water hyacinth. So just like invasive species can have really negative impacts in terrestrial ecosystems, they can here as well. And they can be both deliberately and accidentally introduced. Okay. Population growth, we know that most people live near the ocean, so that's a problem. Climate change. Let's look at a specific example of climate change related to increased carbon dioxide in the atmosphere, and that's coral bleaching. So when carbon dioxide in the atmosphere increases, then more carbon dioxide dissolves in the ocean. Carbon dioxide and water, when they mix, create H2CO3, carbonic acid. Okay? So this leads to ocean acidification. So when we have a lower pH, coral bleaching happens. Basically what's happening, if you look at the chemistry of coral bleaching, that carbonic acid can break down and into its ionic form. And then the calcium carbonate that's normally incorporated into the corals and the shells of animals, the carbonate part of it has a stronger attraction to the hydrogen ions and the calcium ions. So it's more difficult for these organisms to incorporate the calcium carbonate, and that becomes a problem. The O, overfishing, right, can lead to the closing of a fishery. And we've seen this, some of the best studies in overfishing have happened with the Atlantic cod. When a fishery is closed, that has major economic impacts on an area. Something that if you follow local news at all comes up pretty much every year due to our large fishing areas in like Gloucester, New Bedford, Fall River, etc. Okay. You do need to be familiar with some industrialized fishing methods. So we're not talking about, a person sitting on the side of a lake or going out in a boat fishing for a few fish, but how do commercial industries fish? So the major examples that you need to be familiar with are trawler fishing, purse seine fishing. So think about that scene in Finding Nemo when they're pulling up the net of fish. That's purse seine. Long lining and drift net. Okay, aquaculture is described in more detail in Chapter 12, which deals with agriculture, because that's almost more like, so fish farming in a cage, as you can see up there in the diagram, that is when we're really growing fish in an area. So that's Chapter 12. Okay, so a lot of the same laws that apply to protecting endangered species on land apply in the ocean and aquatic ecosystems as well, like CITES and the Endangered Species Act, and also the Marine Mammal Protection Act is another good one to know. Get some case studies here looking at how with whales and turtles, so species that are endangered, what are people doing to protect those? So general solutions that we can use for aquatic ecosystems. There are moratoriums, economic incentives, or ecotourism can be helpful, marine sanctuaries and reserves, education, always a good solution, and then restoration of aquatic ecosystems as well. In terms of managing and sustaining marine fisheries, I like these figure 1111, kind of gives you a nice recap of the examples and specific ideas within those. So you always know in FRQs you must be specific. Okay. And then 11.4, protecting and sustaining wetlands. So as I mentioned in the Chapter 8 video, Boston was once pretty much all wetlands. It was filled in. There used to be more hills in the greater Boston area, and they took gravel from those hills in the 1800s and kind of filled it in. Back Bay used to be more of a bay than it is streets and buildings. So now, if you wanted to do this, mitigation banking would come into play. So basically, mitigation banking allows the destruction of wetlands in one area as long as equal or more area is created or restored somewhere else. So this can be used for sustainable development. The case study about the Florida Everglades is an excellent case study. Florida Everglades showed up on an FRQ a few years ago. Gives examples of water diversion, agriculture, how pollution can affect wetlands. So definitely read this case study and check that out. If you've ever been to southern Florida or through the Everglades, you might be a little bit familiar with some of this. And then 11.5, how should we protect and sustain freshwater lakes, rivers, and fisheries? Again, more examples of invasive species, zebra mussels, Asian carp, the sea lamprey, which if you are not familiar with what a sea lamprey looks like, they're really nasty. So invasive species have had a major impact on aquatic ecosystems. Dams and diversion projects, so when we're changing the flow of the river, can interrupt the ecological services that are discussed in figure 11.16. So things like if you build a dam, then that changes where silt is deposited, so it will build up behind the dam and it won't make it down into the floodplain, which will then affect the nutrients that are available, for example. Additionally, dams can interrupt the migration of spawning fish like salmon, which must swim upriver. So that could be a problem as well. And then 11.6, what should be our priorities for sustaining aquatic biodiversity? Kind of summarizes it, and that's Chapter 11.